So, good evening, all. Welcome. So, hope you can hear me clearly and also see the slides. So, if you can see, just give some feedback. Okay, yes. Thank you, Deepika. Thank you, Nivedya. Yes, good that you can see. All right. So, we'll just wait for another maybe 1 or 2 minutes so that the other participants can come in. So that all of you can attend together. So yeah, so hope you have all solved the project problems. So I had not looked into the solutions whatever you had sent, but I saw around 20 people have submitted it, which is good number, I guess. All right, so I'll be not accepting any more project submissions after this, so it has been closed right now. And we'll be doing a small discussion of the solutions today, and hope that's fine for you. All right, so those who have solved the project submission and want more time, please give +1 in the chat box if you want more time to submit, maybe today till something like 8 p.m. Then I'll just skip the discussion of this project part. Anybody would like to submit the project till 8 p.m. today? I'm just asking in case somebody has missed the deadline and want to do it. Okay, I think nobody wants to do the project questions once again. That's fine. All right, I get no feedback. So once again, so I'll proceed with the project discussion for the first half. Then we will learn a little bit about extensions of multiplication. Is that fine with you? If it is fine, then give a thumbs up. Or if you don't care, you can write don't care. Just yes, no, don't care, or thumbs up. Anything. I can't see anything on the chat box. So I'm waiting. Okay. So I think the chat box is not getting updated for me. The last time that I see is 1734. Can you give a thumbs up if it is okay that we continue? Guys, can you hear me? All right. Okay, so I'll go ahead with the project discussion today. Hope you are all able to see. So question number 1, we shall just read it. So find the missing digits in order in each box below. So we have this 3-digit number which is added with the second 3-digit number, and it gives a 3-digit number itself. Now you are to find what is missing in each of these boxes. So let us see what is in box in the bottom. It is just 2 plus 8. It is 0 with 1 as a carry. So I'll just write like this. Now this 1 carry has to add with 7. So 7 plus 1 is 8. Something plus 8 has to give the units digit as 7. So the number has to be 9 here because 8 plus 9 is 17. So that will again have a carry which is going to the next place. So this carry plus 3 will make it 4, which means the answer here is 0. So I'll just rewrite what is the solution. 0, 7, 2 plus 3, 9, 8 is 4, 7, 0. So this is what the solution is. It's almost direct. And what sutras did you use here? Here you are using the completion sutra, which is the 10-point circle by completion and non-completion. 2 plus 8 is 10. And that 1 you carried over. Here again you get 10 plus 7. So you are getting a number 10 here. So again it's by completion and non-completion. And then next is a carry, which is just simple addition. 1 plus 3 is 4. So if you have understood and if you want further explanation, if you want, please write that on the chat box. So unfortunately, I don't see my chat box getting updated. Okay, let me just try that once again. Guys, can you hear me? And can you write on your chat box? Okay, now the chat box has completely gone off for me. All right. Let me do one thing. Let me just reopen this. Sorry guys for delaying this. All right. Okay, now I get the updated chat. All right, good. So I think all of you are fine. Yeah. Yeah, sorry I had to miss a few of the chat elements because my screen was not getting updated. Yes. So I think many of you are giving thumbs up. So let's move on to the second problem. So the second problem is a word problem. Now this word problem reads the following. Gautam goes to the supermarket. He purchases 4 notebooks for 17 rupees, 3 pencils for 3 rupees, 2 rulers for 10 rupees and 1 eraser for 5 rupees. He has 100 rupees in total. Which item should he return so that the bill is the greatest number which is not exceeding 100? So that is a question. Yes, many of you have given the answer. The answer is pencil. Good that many of you have already solved for this. So let us just solve it quickly here. So the entire problem here is that you'll have to compute what is the total rupees. Okay, so 4 notebooks, 17 rupees. So 4 times 17. What is 4 times 17? You do 4 into 20 and you can subtract 12. Why 4 into 20? Because 17 is closer to the base 20, which is a multiple of 10. So 80 minus 12, which is 68. 68 plus 3 times 3 is 9. 68 plus 9 is 77. 77 plus 20, that is 97. 97 plus 5, which is 102. So 102 is the total spent money for this bill, but he has only 100 rupees. So which means he has to return at least one item. Now which item he should return so that it is the greatest number close to 100. Now he might return a pencil, or he might return a notebook, or he might return a ruler or an eraser. Now notebook is just, if he returns one notebook, it's 17 rupees. So that's not a good idea, isn't it? That's not a good idea. So it's a good idea to just return one pencil because it's costing the less. So we got 102 as the total. So he has to subtract 3, which makes it 99. So he should be returning a pencil. It's a quite direct problem. So this is what happens generally when you go to the shop and you lack some money. Then this is what you do. You give the cheapest item back. So this is the same problem. So hope you guys have got this answer. Shall we proceed to the next? All right. So this is the bonus question that I had given. The first two were actually the questions that needed to be solved. This is an optional question now, the bonus one. So find the numbers in each of the boxes here. So that's a question. Now I'll just give you maybe 60 seconds. Can you just identify? Okay, I can see answers coming in, which is nice. So congratulations, somebody by the name primary school is solving it. So probably the question was so easy. But I was thinking the question is a little bit hard because seeing all the numbers here, it's a little bit difficult to comprehend where to start. All right. Okay, Himanshi says that please do not solve this question here because she has not tried it. Okay, so I'll not solve the question, but I'll just give a hint on where to start so that it will just be clear to give a stepping stone, right? So I'll just give you some hint on where to start so that it becomes easy for you. All right. Okay, there are so many comments coming in. So looking at the Himanshi's comment, I'll not solve the entire problem. So where you can start is probably like this. You can call one of the variables as x and the other variable as y. Okay. Now, when you have variables, x can take some value and y can take some other value. All right. So here you get what is called as an equation. So probably you know what is meant by an equation. X plus y equal to 23, that is an equation. And here what you can do is, since x plus something gives 13, you can put here as 13 minus x. All right. I'm just giving you a hint. I will not solve. Now in the second, you can just put y minus something is 6. So this something should be 6 minus y. Is that correct? Because y minus 6 minus y should be 6. Now what you get is a set of two equations. Now you just have to solve. All right. So I'm not telling you the answer. So Himanshi, you can try it for yourself. Okay. All right. So we are going to today's lecture now. I had just spent 15 minutes for discussing the project. So I have already closed the project today. So those students who wish to again submit, I'll just open it till today 8, but you will not be valued. I'll only value the first 20. All right. All right. So let's get to the introduction of number system. So everybody uses numbers, and these numbers have got a system. What do you mean by system? You have got different kinds of numbers. You have the counting numbers, which is also known as the natural numbers. Then after that you have the whole number, which includes 0. Then you have integers, which is a larger class. Then you have got rational numbers, which is all the fractions. And then you have irrational numbers. And finally, you have something called as a real numbers. I'll just write it for you so that it becomes clear. You have already learned this, but some of you might actually want to see what the number system looks like. So you have the natural numbers or the counting numbers. On top of the natural numbers, you have what is called as whole numbers. On top of whole numbers, you have the set of rational numbers. Oh, sorry, integers. I should write integers. Rational numbers is above integers. Let me use eraser here. Right. All right. So here is a class of integers. Here is the class of rational numbers. So in this set of sessions that we'll see, we'll only go up to rational numbers. Rational numbers are also known as fractions. So what is an example of a fraction? 1 by 2 is a fraction, 1 by 3 is a fraction. You can even write these fractions as 0.5, 0.25, etc. So there is a decimal representation for the fractions as well. All right. So let us go into some history of the number system. So the number system is believed to be originated in India, and initially the number system was thought to be like alphabets, more like alphabets. It doesn't have the current Arabic script. So what we use today is the Arabic script. So previous to that, the Romans had a different set of representation, which was identified to be a little bit difficult, so that we are using only for a specific purpose, because the Roman numbers are difficult to write because it requires alphanumeric kind of approach. So this is how the ancient people wrote numbers. So this is in different time periods it is being shown. So in Ashoka's time this was there, Gupta, Kalinga, Vakataka, I think Nepal, something Nashik, Nanagat, all the different civilization, they had different number representation. Now, even when you go to different languages that are there in India, you can see this variation there that is there. So in Devanagari, you have a specific way of writing. If you go to some other South Indian languages, Telugu, it might be different. Tamil, it might be different. Kannada and Malayalam, it will be different. Okay. So the evolution started in India, but what we use today is the Arabic script. Yeah, so the Roman and the Greek were also common systems that were used in the West, but currently we have standardized this representation to the Arabic system. Now, one important English mathematician who studied about the number system is Fibonacci. Most of you might have learned about the Fibonacci. And the Fibonacci system is, Fibonacci in his book called as Liber Abaci, he describes the current number system that is being used throughout the world. Now, what happens is that when different civilizations use different scripts, at a time it was required to standardize this, and this particular work by Fibonacci is one of the works which helped in that standardization. So we have the common number system that is existing today. All right, so the number system also extended to decimal system. Decimal, all of you know what is decimal by now, because we just told about fractions, and we told that fractions can also be expressed as decimals. So for example, 1.5 is a number which falls in the decimal representation. Now this representation is so very important in the computer, because we are using what is called as binary arithmetic, and there we use a particular arithmetic called as floating point. This floating point arithmetic is very important, and it essentially comes from that decimal representation. All right, so there are some other representations also that exist. For example, in computers, again, you have base representation, base 2, base 8, base 12, and base 10. So in computers, we generally stick on to base 2 and base 12. These are known as binary and hexadecimal. So most of you might have heard binary, at least most of you might have heard. All right, so let me just stop here to check the chat for a little bit. Yes, so Sirisha asks what is the the Fibonacci sequence. Okay, so when I mentioned Fibonacci, yes, Fibonacci, the mathematician, is known for the sequence, which I will talk to you a little bit later. But now I was talking about the book written by Fibonacci about the number system. All right. So Ashlesha is asking where I can get the link. So link to what? Uh, Link to the project. Project link is available in the previous session video, session 3. In the description box, go to the link in the description. There is a Google form available there, and there you will get all the details about the project. All right. Okay. Okay, so let me just continue. So if I had missed some questions in between, I'll just take those questions when I stop next. Okay, so have a little bit of patience. So the example here that is being represented is how we can write a number in terms of its place value and face value. So there is a place value system and there is a face value system. So for example, the number 345 can be written as 300 plus 40 plus 5. Now this is essentially showing that this can be in the hundreds place, this is in the tens place, and 5 is in the units place. So 3 is the face value, 4 is the face value at the tenth place, 5 is the face value at the units place. All right, so that completes our discussion about the number system. Now let me just show you where we are as part of the syllabus goes. So we have already completed 3 sessions. So today we are focusing on creative mathematics. So creative mathematics meaning that you should use different methods to solve the same problem. So for example, some students might be able to do the multiplication of 16 times 16. All right, because they might have come across the multiplication table of 60. But some other student may not have. So in that case, what we should do is we should apply some amount of creativity and intelligence to do the 16 times 16 in a faster way. Now, how do we do that? We will use a technique called as doubling and what is called as number splitting. So there are two techniques. It's called doubling and number splitting. So today we will be talking about the doubling operation. So halving, probably there will not be time. If there is time, I'll surely touch upon halving, which is again a reciprocal or a complementary operation. All right, let's go. So we are going to little bit talk about how to play double role. So you might have watched in some movies how double roles come into play. Now these double roles happen in mathematics also. So the storyline here is that you should use some creative ideas. So by creative meaning you can use something which is innovative or new. Now I told the example of 16 times 16. Anybody knows without calculating what is 16 times 16? Yes, as I had predicted, Sri Karthik says it is 256. Very good. So you have come across the table of 16. Suppose you did not have any idea about what is the table of 16, still you should be able to do it with reasonable time. How will you able to do this? 16 is nothing but 2 times 2 times 2 times 2. Everybody can see this? So 16 I can write it as double of 8, or 8 can be written as double of 4, 4 can be written as double of 2. So 16 consists of 4 2's, 2 multiplied by 2 multiplied by 2 multiplied by 2, and 16 here also can be written same as 2 multiplied by 2 multiplied by 2. So what you have to do is you double at the number 16 every 4 times. So 16 multiplied by 2 is 32. 32 multiplied by 2 becomes 64. 64 multiplied by 2 is 128. 128 multiplied by 2 is 256. So if you did not follow, don't worry, we are doing enough examples from the beginning. This is just an example. Alright, so we are going to do easy multiplication, and we are going to expand the multiplication table. Suppose you knew multiplication tables up to 5, we are going to extend it to maybe 10 or 20 or even larger than that. I'll show you how you can grow your multiplication table. Now, when you are studying about doubling, especially we are looking at multiplication by even numbers. So today I'll be talking more on expanding multiplication table for even numbers. And the third technique that I'll be showing is how to understand the number splitting operation. Now, number splitting is quite easy. What you have to do is you have to segregate the total number into parts so that it can be easily doubled or halved. So for example, if I want to do the double of 256, which means I have to multiply 256 by 2, one number splitting that comes is you can split at 25 and 6. So this is how you can do number splitting. You split the number 256 into two parts, 25 and 6. Do 6 multiplied by 2, do 25 multiplied by 2. So this is what is called as number splitting. Alright, now let's look into detail about the doubling operations. Now the doubling operation would especially be useful if you are multiplying by the numbers 2, 4 or 8. It is very obvious, right? Because by multiplying by 2 or 4 or 8, you are just having a multiple of even numbers. Now, as I said before, we will have to use something called as number splitting. Now, in Vedic mathematics, we call the number splitting operation as anurupena. Okay, the word in English approximately translates as proportionately. So what is anurupena? Anu means something that is similar. Rupena means something that has rupam means something like shape or something like that. So you repeat the same operation by number splitting. That's in approximately what it means. So let's do some examples. Now doubling is same as addition. Everybody can understand this. By doubling is same as addition. Let's take the example of 16 only. So if I have to do 16 multiplied by 2, it is same as 16 plus 16. Now every multiplication can be written in terms of an addition. It's not a different thing, but just to make calculations easier, we are using this new notation of multiplication. All right. Now the question comes here. Try doubling all these numbers. What is the double of 24? What is the double of 14? What is the double of 25? What is the double of 36? So if you know the answer, I'll give you exactly 30 seconds. You can write the answer as A followed by answer B, B followed by answer, C followed by answer, and D followed by answer. It's quite direct. Yes, I can see a lot of answers coming in. Right. Yes, Sirisha, Kalyani, I can see your answers. Deepika, Pavitra, Adityan, good. Ashlesha, Charan, good. Alright, let's see how we can easily compute it. Now 24 is a two-digit number, isn't it? So we'll introduce the Anurupena or the proportionality here. 24 can be written as 2 and 4, and you can separate it. Now what you can do is you can double both of them, double both the sides. So this is 4, 8. Double of 4 is 8, double of 2 is 4. That's why the answer is 48. Let's apply similar doubling here. 1, 4. Double of 1 is 2. Double of 4 is 8. So here is the double. Now let's look 25. 25 is a little bit difficult, but most of you might know that 25 multiplied by 2 is already 50. So when you do the doubling operation of 25 by Anurupena, you can do the following. Now in Vedic mathematics, we usually approach from left to right rather than right to left. So the double of 2 becomes 4, double of 5 is 10, but 10 I will just write it like this, just 1 below the number 0. So this will be treated as carry and this will be the answer 50. All of you got it? How we got 50? Because we are just carrying this one operation to 4. Now 36 also can be found out using a similar method. Double of 3 is 6, double of 6 is 12. 12 can be written like this. So the answer has to be 72. So hope all of you got this. If you have got all the 4 answers, you can give a thumbs up for yourself. All right, good. So why I was explaining even for the simple examples is because when we go to larger examples, this tool is very convenient to use by number splitting. Okay, so this was by number splitting. Let's take one last example, how to do number splitting and do the double of 68. Okay, so for these numbers 68, what you can do is you can slice the number or split the number as 60 plus 8. 60 plus 8 is 68. Double of 60 is how much? It is 120. Double of 18 is how much? It is 16. So 120 plus 16, the answer is 136. So what we get is, by applying this Anurupena, we get that the answer is 136. The double of 68 is 136. All right, yes. Sorry that this has to come at the beginning. So this doubling operation is similar to just addition. That's what this picture just symbolizes. You can see the two people are just adding together to form a single image, just like that. So one way of thinking in terms of image is that, I don't know how many of you know what is the negative of an image. So in maybe 20 or 30 years before, you had what is called as the film roll. The film roll used to have the photo part, the color part. I'll just call it as P, and there is something called as the negative. So P and N, these are two sides. So N will not have any color, P only has the color, but when you add these two, you get back the original, something like that. So the doubling operation is something very similar to that. You split the same number into two parts and then you add it together. All right. So we are ready to go to the next part, which is for larger numbers. How do we do the doubling operation? So I'll just do a couple of examples. Can you double the number 273? It is possible. I can write the number 273 as 200 plus 70 plus 3. I can double each part. Double of 200 is 400, double of 70 is 140, and double of 3 is 6. So if I add this back, I'll get, so 400 plus 140 plus 6, it is 546. Now let's do another example. This time I'll leave for you. I'll give you exactly 20 seconds. Please post your answer if you get the double of 636. Right, I see the first answer by Srikanth, which is nice. Anish gives the second answer. Sirisha, good to see that you can solve it fast. So 636, we can do this digit by digit also. What is the double of 6? It is nothing but 12. I'll just write like this. Double of 3 is 6. Double of 6 is 12 again. Now this answer, you can take one carry here. This is not a carry because this is the last digit. So the answer is 1272. So this is just by splitting each of the digit wise. But if you don't like this method, you can do another method. Write this as 600 plus 30 plus 6. You can double 600, which is 1200, double 30, which is 60, double 6, which is 12. So 1200 plus 60 plus 12, which is 1272. All right. So here I have given a few more practice problems. Now let us solve one by one. So I'll not use now the splitting. I'll try to do within the mind. You can also try to do in the mind. So I'll be a little bit loud while I do this. So the double of 362 is the double of 362. 62 double is 124. 124 plus 600 is 724. What about the double of 453? I'll split the number as 450 plus 3, which is double of 450 is 900. 900 plus 6 is 906. What about 612? 612 is 600 plus 12. So double of 600 is 1200. 1200 plus 24, because double of 12 is 24. So 1224. What is the double of 319? Double of 300 is 600. 600 plus 38. 600 plus 38 is 638. What about 707? 707 is nothing but, if you double it, you can do number splitting as follows. Digit by digit also you can do. So double of 7 is 14. Then you have 0. The double of 7 is again 14, but the last digit need not be carry. So the answer is 1414. So except for the last one, I have done everything in the mind. All right. So hope you all got it. Now if you have any doubts on this, you may ask that in the chat box. I'll just wait for a couple of minutes. If you have any doubts, if you want some problem to be repeated, please put that in the chat box. Okay, I think the concepts are fairly direct. We have not tried. Yes, Anish. Okay, yeah, I remember you, Anish. Yes. Tejas says he wants to repeat the number splitting method. Okay, so let me just explain the number splitting method once again. Let me use the eraser so that it is clear to you right now. So I want to double the number 273. So the number splitting method is fairly direct. What is the number splitting says that you can write the number 273 as 200 plus 70 plus 3. Now doubling means you have to multiply by 2. So this cross 2. So double each part. So double of 200 becomes 400. Double of 70 is 140. Double of 3 is 6. So the answer is 546. So this is the first example. Now let me just do in a different method also. That's the second example. Let me just erase this. I'll just explain it once again with more clarity. So one way, as I told, is you can use the same number splitting in tens place, units place, tens place and hundreds place. You can separate the numbers 3, 6, 36 like that. In that case, you will have to double 600, double 30 and double 6. So double of 600 everybody can know, right? Because that is easy. It's a single digit number. It is 1200. Double of 30 is 60. Double of 6 is 12. So 1260 plus 12, 1272. So that is one way. Now the other way is you can do digit by digit multiplication. Digit by digit doubling is convenient here. 6 multiplied by 2 is 12. There is one carry. Remember that in your mind. Then twice of 3 is 6. So 6 plus that carry is 7. And then in the last part you have the double of 6, which is 12. So first we got 2. 1 was given carry to the next place. So 6 plus 1 is 7. Then the last part is just double, which is 12. So that is how we got that. All right. Now suppose you want to create a movie with 4 roles, the same person repeating 4 roles. So in that case, we'll have to multiply by 4, right? So what is the easiest method? You first double, then double it again. Okay. So multiply each number on the left by 4. So you have to start with this number and multiply by 4. But we have already done the doubling operation. So let us do this. What is the double of 273? It is nothing but 546. Now you have to compute just the double of 546. It's convenient, right? So double of 46 is 92. Double of 500 is 1000. So this is 1092. All right. Now double of 636. That's also convenient. Double of 600 is double of 636 is already computed, which is 1272. I just have to double this. What is the double of 1272? Yes, to compute it, you have to split the number. So 1200 plus 72. What is 1200? It is 2400, double of that. 2400 plus the double of 72, which is 144. So 2400 plus 144, 2544. 2544 is the answer. Somebody gets a different answer? No? Okay, somebody says doubt. I think Padmini, you have a doubt? Yeah, please write your doubt in the chat box if you have. Okay, somebody says, Himanshi says, I'm very confused in doubling and splitting. I'm not able to do any sums in mind. Don't worry, if you are not able to do the sums in mind, let's just for clarity, just take one more problem from the practice here. So this is for those students who are finding the number splitting and the doubling, etc., to a little bit difficult to do in the mind. So for them, let's do the following. we have to double the number 724. So this number 724 can be split as 700 plus 24. This is clear? Himanshi, is this clear for you? 700 plus 24. 362 is, oh, I'm sorry. The double of 362 is 724, which I am writing it as 700 plus 24. It's quite direct, yes. Now I have to double this. So you just have to apply distributive property here. So you just have to distribute 2 multiplied by 7, which is 14. So 1400 plus 2 multiplied by 24, which is 48. So 1400 plus 48 is nothing but 1448. It's just 1448. Alright. I'll just show one more example so that it becomes clear. 906. I'll just write this implication sign because we are just doubling, though it is not the correct notation. So 906 is 900 plus 6. I just have to double it. So imagine that you are making 2 copies of this. Let's do like that. 900 plus 900 is 1800 and 6 plus 6 is 12, which just makes it 1812. Yes, very good. So many of you have got the answer right, which is a good sign. Let's go forward then. All right. So I think I had missed the doubt of Padmini. Okay. Doubt in finding the numbers in boxes. Okay. So that's the bonus question. So for Himanshi, I had just left that question for the next class. So because Himanshi wants to solve it today, I'll just leave that discussion for the next class. Okay. Now let's just continue with some more examples of multiplication by 4 and 8. So we had learned how to double. We had learned how to double of double, which is multiplication by 4. Now double of 4 is 8. That is what is multiplication by 8. So double twice for multiplying by 4. We have already seen how to do this. So this is just some simple more examples on the same thing. So 35, the double of 35 is 70. 70, if you double it again, it is 140. It's nothing. It's, you can do everything in your mind right now, right? Think of 35. If you are little bit finding it difficult in the mind and you want to go slowly, what you can do is you split the number 35 as 30 plus 5. So 30 plus 5, you double it, 60 plus 10. Why? Because double of 30 is 60, double of 5 is 10. So 60 plus 10 is 70, and you again take double of that. Double of 70 is 140. Got it. All right. So let's do again multiplication by 8. So what is 26 multiplied by 8? So let's do doubling 3 times. So this is doubling 3 times. So if I just double 26 once, it is 52. If I double it again, how much I'll get? 52 double is 104. Double of 104 is how much? It is 208. So the answer is going to be 208. So if you directly want to do multiplication of 8 with 26, what you will generally do is a difficult operation, isn't it? Just think of this. 8 multiplied by 6, 48, you do 8 multiplied by 2, 16 plus 4 you do, which is 20. Now this involves calculation of multiplication tables more than 5. Some of you may have difficulty in learning up these multiplication tables. So the easiest way, even for those who know the multiplication table of 8, the easiest way to go is like this. You double 26, you get 52. 52 double is 104. 104 double is 208. Good. All right. So the sutra that we used here is called as Anurupyena. All right. That means approximately proportionately. Now, the reason why it is called proportionately is the following. I'll just take the same example. So 26 I am doubling. I am writing 26 as 20 plus 6. This is the number splitting that I used, and I am multiplying this. Now the distributive law itself is what is called as proportionately. I am just distributing the 2 between 220 and 6. Okay, Kalyani says that I want more time. Okay, you can take some more time. I'll just wait for 1 minute for you to digest. All right, we have done nothing new here as such. We have only learned a single operation, which is doubling. And with this doubling, we are just taking many permutations of the operation. Yeah, so Himanshi is saying, I did multiply as you multiply in paper from right to left, but that in mind. Okay, good. If you could do it in mind, that is good. But generally, what I say is that, okay, so you are saying 26 multiplied by 8, you did it in the mind. I think that is what you're saying. So, yeah, if you know the multiplication table of 8, it should be perfectly fine. Otherwise, the other number splitting operation is 20 plus 6. You can find multiplication by 8 as 20 multiplied by 8 and 6 multiplied by 8. That's also fine. Oh, somebody says 52 is the answer. So Ashlesha says 52 is the answer for what? So 52 is the double of 26. Correct, correct. Yes. Yes, Roshini also says that it is fine. She could do it in the mind. All right. So I think we can go to one more part. All right, we have some practice problems more. I have a easy set and a hard set. Let me just show you the easy set. So let us do one thing. Let us do a timer here. I don't know if I have put the timer. Oh no, I don't have a timer. So let's do one thing like this. Let's go with the easy set first. Your time starts now. I'll just give you 30 seconds for each of them. If you get the answer, you just write E followed by the answer 1, comma, answer for second and the answer for third. So E stands for easy. All right. So let me just wait for just 1 minute and 30 seconds, which is 90 seconds. Good. Okay, Sudhakar, we have 3 minutes more, so you can solve the problem. After that, you can leave. All right. I think students are feeling hungry. All right. Right. 212, right. So let me just see who has given the first set of answers. So I'll just only look into students who have written all the 3 answers. Prashanti has given the answer, seem to be the first. Good. Okay. Let's see if the answer is correct or not. So 53 multiplied by 4. This is what we have to do, right? So 53, I can write it as 50 plus 3. Now 50 multiplied by 4 is 200. 200 plus 3 multiplied by 4 is 12. So 200 plus 12 is nothing but 212. Now what is 18 multiplied by 4? You can use doubling. The initial method I just multiplied by 4. I was just using multiplication table of 4. Here I will just do doubling. Double of 18 is 36. Double of 36 is 72. The answer is 72. So I am talking loud so that you know what is what are the calculations that I am doing in the mind. Now 22 multiplied by 8. What is 22 multiplied by 8? You can do double of 22, which is 44, double of 44, which is 88. So that is multiplication by 4 only. Now if you want to find multiplication by 8, you multiply 88 with 2. What is double of 88? Double of 88 is 160 plus 16. What is 160 plus 16? 176. Good. Now for those who find this difficult, I'll show another method also. 22, you can write it as 20 plus 2. You do 8 multiplied by 20. Everybody might be able to do that because we have already learned double of 8. Double of 8 is 16. So that is 160. 160 plus 16, which is 176. Alright, hope you have got it. Let's go to the hard part. Again, I'll give you just 1 minute this time. Every problem here is to multiply by 8. Some of the problems we might have already solved in the previous slide. Alright, so I'll give you exactly 1 minute. Now the time is 6:30. Next 1 minute you can spend on this. This will be the last set of problems. Try to do it in your mind if possible. Okay, Deepika comes first, Adityan comes second, Satvik just gives the first answer, which is good. Okay, I'll count you as well. Okay, yeah, Rajiv, you have given the right answers for the previous one. All right. Oh, it's not 6:31 seconds. It is time 6:31. Now it is 6:30. I'll just stop it at 6:31. Good. So we have maybe 10 more seconds. All right. So I have got plenty of answers, which I think is almost many of you are getting the same set of answers. So I'll just give you the answers. I'll just do it in the mind. So 362 multiplied by 8. So 300 multiplied by 8 is 2400. Sorry, is it correct? 2400 plus 480. 2880. 2880 plus 16. 2896. The double of 453 is nothing but 906. Double of 906 is 1812. Double of 1812 is nothing but 3624. Are we right? I think we are right. Double of 704 is 1414. Double of that is 2828. Double of 2828 is nothing but 5656. Good. So I think many of you have got it. If you have not understand, I see one message by Vilasini. No problem if you have not understood this. Take your own time because I was doing it in little bit fast towards the end. And anyway, it is a practice question. So if you have not solved it, kindly write the question in your notebook and take your own time, and then we'll discuss it tomorrow. Okay. So that brings us to the end of today's session. Hope you enjoyed it. So only thing to take back is remember double rule. That's what today's session was about. How to do doubling, how to multiply by 4, how to multiply by 8. Now I'll show you some examples more with practical application where this doubling operation comes. So I know that there are many people who use computer, many students use computers, and many students are watching this video on mobile phones. So in mobile phones, this doubling operation, the multiplication by 8 and all is used extensively. Okay, so I'll just give you a story for connecting this doubling operation tomorrow. with whatever you are watching now, etc. All right. So this is one sentence that I have taken from the Vedic mathematics book. And it says the sutras, the Vedic mathematics sutras, are very short. Once one understands them, the whole thing becomes a child's play and ceases to be a problem. So we are trying to make mathematics a play more than a problem, more like a story than some equations. Okay, so this is the gist of what we have learned. So thank you. Hope you enjoyed, and namaste.